You might think of a number as just a number, but in mathematics, numbers can be grouped into certain sets, and you might be given that set as a condition to a particular rule. So it's useful to know what some of these sets mean, and that's what I'm going to do in this video. Our starting point is with natural numbers. You can think of these as counting numbers, such as when we are counting objects. So for example, it might be the number of sweets in a jar or sheep in a field. If we put a 0 or 0 on the front end of this set of numbers, we now have a set of whole numbers. So natural numbers are without the 0, and whole numbers are with the 0. But what about negative numbers? If we include the numbers -1, -2, -3, etc., we have now created a set called integers. We can also write them like this: +or -1, +or -2, +or -3, and so on. Notice that there is no fractional part to this set of numbers. That is, there are no fractions or decimals included in this set. So now let's write a set of numbers to include fractions and decimals. These are rational numbers. A rational number is a number that can be expressed in the form of a fraction a over b, where a and b are integers and b does not equal 0. Remember that something over 0 cannot be defined. Some examples of rational numbers are 0.25, which we can write as a quarter, or 0.6 recurring, which can be written as 2 over 3. Whole numbers such as 4 can be thought of as 4 over 1, or 12 over 3. And negative numbers like -5 can be thought of as -5 over 1, or -15 over 3. If we consider the sets of numbers we have looked at so far, our main family are rational numbers. Integers are a subset of rational numbers. Whole numbers are a subset of integers, and therefore a subset of rational numbers. And, of course, natural numbers end up being a subset of whole numbers, which also means that natural numbers are a subset of integers and a subset of rational numbers. Having mentioned rational numbers, I feel it is important to mention irrational numbers. Unlike rational numbers, these are numbers that cannot be expressed as a fraction of one integer over another. The two most familiar ones are pi and the square root of 2. Irrational numbers sit outside the other set of numbers. However, all these sets of numbers can be grouped into one set of numbers, and that is real numbers. I mentioned real numbers in a previous video where we looked at functions. All that real numbers means are numbers that can be placed on a number line. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. I suppose we ought to mention even and odd numbers. Even numbers are integers that are exactly divisible by 2. In algebra, the nth term for an even number can be written as 2n, where n is any integer. An odd number is any integer such that when it is divided by 2, it leaves a remainder of 1. This can be expressed in algebraic form, where the nth term can be written as 2n add 1, where n is any integer. So there's a brief introduction to the language used to describe some sets of numbers. It is useful to understand what these mean, as particular sets of numbers are used for certain conditions. In this video, when I was describing rational numbers, these are described as numbers that can be expressed in the form of a over b, where a and b are integers and b does not equal 0. It is therefore helpful to understand what we mean by an integer. I will talk about rational and irrational numbers in more detail another time. But that's it for now. I hope you found the video helpful, and thank you for watching.